So we've seen how an integral appears through either looking at areas under curves or as antiderivatives, and we've shown how those are the same thing. What is actually the meaning of the integral for functions in general? It's not quite the area under curves because we've assumed in everything that we've done that the function involved was positive everywhere on the interval. What about when it's negative? Let's have a look at that. The integral from a to b of f of x is an area provided the function is positive over the interval a to b. But what about if it's not? What happens then? Let's consider the integral from 0 to 2 pi, and let's evaluate this using the evaluation theorem. That tells me that I can choose an antiderivative of sine, which is minus cosine, and evaluate that between the two limits 0 to 2 pi, where I'm using a vertical line to say I'm evaluating it. First at the top limit minus that at the bottom. It's relatively easy to show that that's equal to 0, which means that it's clearly not telling me an area. But let's look a bit more closely what's going on. Let's draw a graph of sine. Let's now, with reference to the graph of sine x, let's have a go at this integral again. Now, what I'm going to do is split the integrand up at x equals pi. Now let's evaluate this using the evaluation theorem. This becomes, and if I just notice what these integrals are, the first one is the area A, okay, and that comes out to be equal to 2. Then we have plus minus 2 from the second integral, and this is the negative of the area B. So this second integral then is minus area B. And so those two areas are cancelling out when we do the integration, which is why we end up with 0. So the integral of a function when it's negative is minus the area under the x-axis. So it's a negative area or minus the actual enclosed area. Let's have a look at the area between curves. Let's look at the area enclosed between these two curves, which is this region in here. Let's set this up as an integral. The enclosed area is always a difference in the functions f minus g integrated from a to b. So provided f is larger than g in that region, then the enclosed area is always f minus g integrated over the region a to b. And this works whatever the signs of f and g. Let's find the area between the sine function and cosine function between 0, x equals 0, and the first point where they cross. Whenever you're given a problem like this in words, draw a diagram. Let's start with cos, now sine, and they cross at x equals c, which implies, in order to solve this, I write this as sine cos squared c equals 0, which implies using trig identity for sine, 1 minus 2 cos c is 1 over the square root of 2, which corresponds to c equal pi by 4. So finding the crossing point in some ways is the hardest part of this problem. The area enclosed is the integral from 0 to the crossing point of the largest function minus the smallest function. So it's very important that you get those two things the right way around, and if your answer comes out to be negative, it means you got them the wrong way around. So now we can just calculate this using the evaluation theorem, which is 2 over root 2 minus 1, or root 2 minus 1.